All right, in this video, we're going to talk about elimination again. This is our last lesson on solving systems of equations. So here is a little if-then statement progression here that I think would be really helpful if you copied down. But I'm just going to go over it real quick. Some of this we have already learned. If the coefficient of a variable, x or y, is the same in both equations, okay, then you subtract the equations. Okay, so you're looking at both equations. So like, for example, here in number 1, you're looking at both equations and you're looking to see if the coefficient, meaning the number in front of the variable, is the same for like both of the x's or both of the y's. Okay, in that case, you would do something. But in this right here, in this number 1, I'm noticing they're both different. See, this is a 2 and this is a -6 for the x's. And then this is a -2 and this is a 3 for the y's. So they're all different here. But just follow me here. If they are the same in both equations, then subtract the equations, okay? If they're opposite in both equations, then add the equations. Okay, so like if this was like a -2 here, -2y, and this was a +2, then you would add the equations. But we don't have that here. All right, but then, so basically all of this right here, everything here, we've already learned. This is just review, okay? We know what to do after that. We eliminate one of the variables. One of the variables would be eliminated, okay, after we add or subtract the equations. And then we solve for the other one and then continue and plug the one we get back in to get the second variable. So today, what are we doing? We are going to multiply one or both of the equations by a number to achieve scenario 1 or scenario 2 to solve by elimination. So what does that mean? Okay, we're going to multiply one of the equations, one or both of the equations, by a number. Today it's just going to be one of them, but you could do both if you wanted. But we're going to try and multiply one of them today by a number. Okay, so what we do is we look at an equation, we go, all right, so how can I multiply maybe this equation so that it would be a situation where I have the same in both equations, or the opposite coefficient, coefficient in both equations. Well, I can take this equation right here and I can multiply it by 3. All the numbers, multiply them by 3. So everything gets multiplied by 3 on the left and the right. And what happens when I do that? This gets multiplied by 3. Let's see, so this thing gets multiplied by 3. This term right here, this gets multiplied by 3. And then this gets multiplied by 3, as you can see here. So multiplying every term by 3. And then what that will do is that'll give me a positive 6x here and a negative 6x down here. And then what I have is I have the opposite in both equations. Okay, so that's what I'm going to do today. All right, so 3 times 2 is 6, so that'll be our positive 6x. And then this will be 3 times -2y, so that'll be -6y. And then equals 4 times 3, which is 12. And then we're going to have our second equation, which I'll just copy right down below, -6x plus 3y equals 0. Okay, so we scaled this first one up by a factor of 3. Now, what I have is one of the scenarios. I have scenario number 2 happening, where I have an opposite coefficient in both equations for one variable. That's the x variable. So what am I going to do? I'm going to add the equation. So I'm going to take this equation and I'm going to add it to this equation. So 6 plus -6, that would mean 6 minus 6. That would eliminate the x variable. Okay, one of the variables is eliminated, then we can solve for the other one. So -6 plus 3 would be -3y equals 12 plus 0 is 12. Okay, so now we can just solve for y, divide both sides by 3, and then y equals -4. So now all we have to do is take this -4 and plug it back into one of these equations, preferably the simpler one. And I think the simpler one would probably be the first one, I would say. So that would be the 2x minus 2y equals 4. So I'm going to just use that equation and plug that back into the first equation. Plug this -4 back in. So I'm going to go 2x minus 2, and then that'll be where my y goes, right there, equals 4. So I'm going to plug in my y, and it's going to be a blue y because it was blue over here. So -4. Okay, so now 2x minus 2 times -4 is a positive 8 equals 4. And then we subtract. We know how to do this, right? We subtract 8 from both sides. And we got 2x equals -4. Divide both sides by 2. And then my x equals -2. And so I have solved this system of equations right here. And I'm done with the process of elimination. The only thing I did was I multiplied this equation up by a factor of 3 so that I could have the opposite coefficient and eliminate the x variable right there. Okay, so how about this one right here? Let's try again. Well, we don't have any of the same coefficients. We have 3 here and a 2 here. Those aren't the same. We have a -6 here and a positive 12 here, so those aren't the same. So what am I going to do to get these, one of them to be either opposite or the same? So like a 3 and a -3, or a 3 and a 3, or a 12 and a -12, or something like that. Well, I can multiply, again, I can multiply this top one by something. Do you know what I would multiply it by? How about multiplying it by 2? Because if I multiplied it by 2, then it would be -12 for the y coefficient, and I would have the opposite coefficient, positive 12, -12. So I'm going to multiply this whole thing by 2, this whole equation, the entire equation. So 3x times 2 is going to be 6x. -6y times 2 is going to be -12y. And then -18 times 2 is going to be -36. And it's just multiplying each term by 2, okay, over here. Okay, so now I have 2x still right down here, 2x plus 12y equals 4. And voila, I have opposite coefficients now by using that multiplier in the one equation. So what do I do now? I can if I have opposite coefficients, what do? You add the equations together, okay? So because I have the opposite coefficient, I add together. So I add, nice big plus sign so you know what's happening right here. We're adding the equations, each term. 6 plus 2, that's 8x. -12 minus 12, well, that's the one that gets eliminated. -36 plus 4. If you're adding two numbers that have different signs, subtract the smaller from the larger and take the sign of the larger. So 36 minus 4 is 32, and it's negative. -32. Okay, so now we have 8x equals -32. Divide both sides by 8. And then 8x equals -4. So we've already found our x. What are we going to do now, folks? What did we do last time? We took our x and we plugged it back into the simpler equation, and we found what the y is. So I'm going to plug it into this equation. It looks, I just like it more. It's got only positives, which I'm a fan of. I like to be a positive guy. And then 2 times that value right there plus 12y equals 4. And now what we're trying to get is one equation with one variable, so we can solve for the y now. We solved for the x, now we're going to go for the y. We use the x to solve for the y. So you're using the x right there? It went right there. So 2 times -4 is -8, plus 12y equals 4. Okay, and then plus 8, plus 8. Okay, so then we've got 12y equals 4 plus 8, which is 12. And then what we're going to do is really just divide both of these by 12. Divide by 12, divide by 12. And then I'm just going to write the answer over here. Y, which is by itself now, equals 12 over 12, which is 1. So y equals 1, x equals -4. And we're done with number 2.